Characteristics of big data. Veracity. Veracity of big data refers to the quality of the data. It sometimes gets referred to as validity or volatility, referring to the lifetime of the data. Veracity is very important for making big data operational because big data can be noisy and uncertain. It can be full of biases, abnormalities, and it can be imprecise. Data is of no value if it's not accurate. The results of big data analysis are only as good as the data being analyzed. This is often described in analytics as junk in equals junk out. So we can say, although big data provides many opportunities to make data-enabled decisions, the evidence provided by data is only valuable if the data is of a satisfactory quality. There are many different ways to define data quality. In the context of big data, quality can be defined as a function of a couple of different variables. Accuracy of the data, the trustworthiness or reliability of the data source, and how the data was generated are all important factors that affect the quality of data. Additionally, how meaningful the data is with respect to the program that analyzes it is an important factor and makes context a part of the quality. In this chart from 2015, we see the volumes of data increasing, starting with small amounts of enterprise data to larger people-generated voice over IP and social media data, and even larger machine-generated sensor data. We also see that the uncertainty of the data increases as we go from enterprise data to sensor data. This is as we would expect it to be. Traditional enterprise data in warehouses have standardized quality solutions like master processes for extract, transform, and load of the data, which we referred to before as ETL. As enterprises started incorporating less structured and unstructured people and machine data into their big data solutions, the data become messier and more uncertain. There are many reasons for this. First, unstructured data on the internet is imprecise and uncertain. In addition, high-velocity big data leaves very little or no time for ETL, and in turn, hindering the quality assurance processes of the data. Let's look at these product reviews for a banana slicer on Amazon.com. One of the 5-star reviews say that it saved her marriage and compared it to the greatest inventions of history. Another 5-star reviewer said that his parole officer recommended the slicer as he's not allowed to be around knives. These are obviously fake reviewers. Now, think of an automated product assessment going through such splendid reviews and estimating lots of sales for the banana slicer, and in turn suggesting stocking more of the slicer in the inventory. Amazon would have problems. For a more serious case, let's look at the Google Flu Trends case from 2013. For January 2013, the Google Friends actually estimated almost twice as many flu cases as it was reported by CDC, the Centers for Disease Control and Prevention. The primary reason behind this was that Google Flu Trends used the big data on the internet and did not account properly for uncertainties about the data. Maybe the news and social media attention paid to the particularly serious level of flu that year affected the estimate and resulted in what we call an overestimation. This is a perfect example for how inaccurate the results can be if only big data is used in the analysis. Imagine that economical impact of making healthcare preparations for twice the amount of flu case. That would be huge. The Google Flu Trends example also brings up the need for being able to identify where exactly the big data they used comes from. What transformation did big data go through until the moment it was used for estimate? This is what we refer to as data provenance, just like we refer to an artifact provenance. As a summary, the growing torrents of big data pushes for fast solutions to utilize it in analytical solutions. This creates challenges on keeping track of data quality, what has been collected, where it came from, and how it was analyzed prior to its use. This is akin to an artifact having provenance of everything it has gone through, but even more complicated to achieve with large volumes of data coming in different varieties and velocities.